Okay, so just let's recap. So last time you built your first current boost converter.
Yep.
You remember?
Mm-hmm.
Good. Now let's test it one more time. Good. And take the multimeter and check the output voltage.
The output voltage.
Yes. So we know the input voltage, yeah? Which is the input voltage?
It's 12.
12. Check the output voltage.
That's the one?
So you can check in the parallel with the LED, of course, yeah, from this point, not exactly on the parallel with the LED, or you can check on the parallel with the output capacitor.
Alright.
Yeah?
So output capacitor is this one here.
Yes.
This one.
Yes.
And this?
In the parallel with the capacitor. What parallel means?
Oh, here.
Yeah. So what is the voltage?
33.
33 volts. So your schematic is working.
Yeah.
Okay? Great. Remember last time I told you here it will be a lot of problems.
Yes.
Okay, let's try to adjust the current. Yeah, the current from the power supply. You see, like now it's like 440 milliamps.
Yeah.
Try to make it 100 milliamps. So adjust the duty cycle and set up 100 milliamps. You can't do it.
No, it's jumping to 250.
You see. So you have some problems here.
Problem.
Yeah, you cannot adjust the duty cycle.
Okay.
Now let's have a look for something interesting. Let me grab the oscilloscope. So basically here on the drain of the MOSFET, we should have the switching signal. You can see your signal?
Yeah.
Yeah, good. Now, you know how the DC current is looking on the oscilloscope?
It's looking like a line.
Exactly. Yeah, so that's the DC.
Yeah.
Yeah? That's how the DC is looking, like a line. So you expect to be a line even here. Now let's check together.
Oh, it's the same.
You see?
Yes, it's the signal is the same like.
Yeah. So you see, that's a problem. Your switching is getting out from the circuit.
Okay.
Yeah. Now that you'll think, okay, that's not a problem. But what this power supply is doing, switching power supply, what the MOSFET is doing, is modulating in amplitude the main power rail, your main power rail. No, that's not a problem. It's going to the power supply. The problem is the same signal you will have on your MOSFET driver. You will have the same signal here. So if I'm trying to check here, so we check the minus, yeah, check here the minus, you can see it's not aligned, and check here the plus, it's not aligned. You can see?
Yeah.
So that's the problem. So based on this, theoretically speaking, so your signal, it will not be like square. It will be something like that. Yeah. So if this is not aligned, so you supply power, something like that, right? It's something like that. Okay. So if you supply power, this kind of power, then the output here, probably it will be something like then it's going up when it's switching. Then here you'll have again something like that.
And then it's going down.
Down. And then you'll have again something like that. Because the switching from the MOSFET is coming back to your driver. Yeah. And it will modulate in amplitude. In amplitude means the voltage. Yeah.
Yeah.
So you can see here is lower, here is higher. And that's what will happen. So this is a problem when you are building anything with MOSFETs and switching, yeah?
Mhm.
So a switching power supply has a very important component which has to be there. It's a must. You know what component?
And it's not here.
It's not.
No.
And special, I didn't put it on schematic because I want you to understand what's happened without that component. What component you know which is smoothing the power? A component which is taking like is taking anything else than a line and is smoothing that line. Remember when we play with the AC and the AC after the diode was like something like that, was something like that, and I said will we be using this to smooth the line?
There was a capacitor.
Exactly, a capacitor. A capacitor, it will smooth the current. So in that way, I will make sure the switching, it will be only here from the drain to the coil, and that's all.
Yeah, but this one is not helping.
That's output capacitor. It is helping because it's smoothing the output voltage. Your output, like 30 something volts. Yeah? That's the reason why we are using a capacitor, to smooth that voltage. Because otherwise it will be switching, it will be like duty cycle.
Yeah.
But we'll be using a capacitor from plus to minus. And on that way, I will smooth the voltage. Okay? Let's try a capacitor.
Oh, you bring back the
the
big one.
Yeah. So where you will put the capacitor onto the schematic. This is extremely important.
You said between plus and minus.
Yeah, but where? Plus and minus. Look. Here is plus. Here.
Plus and minus.
Look, here is plus. Here is plus. Here is minus. Yeah? Here is plus. Here is minus. Where it is more. Here is minus. Here is minus. Yeah? Here is plus. So where you will put it?
Wait, you said this capacitor is for output.
Yeah, here on the output. Look, check here. The output is smoothing this.
Yeah.
Yeah.
So that means this one, it should be on input.
Yeah, here I said between the plus and minus. Yeah, that's what I said. Now you can put it here. Yeah, like that. Like connect from here. Have plus and have minus. You connect to ground. Yeah. Or I can put it here. Same. Yeah. Here, or I don't know, you can put it anywhere. Where you will put the capacitor, this is the whole theory of the switching power supply is based on the capacitor placement. Where you will put the capacitor?
Get back to the... So, wait a second.
Yeah, I'm waiting. This also it will explain. You remember the capacitor which I was removing from the laptops, and people said, "Yes, Sorin, what the capacitor is doing? Yeah, we're gonna find out now."
Yeah, but you said this capacitor is gonna give you the smooth signal.
Exactly.
So you have.
You can put it anywhere. That's what you said. Yeah, I can put it here or here will be the same thing because it's between plus and minus, right?
Yeah, but if you want a smooth signal, you want the smooth signal from the beginning. So you're gonna put it on there.
The beginning, this is a wire. What do you mean? This is right. It's a wire, 0 ohms, right? It's a 0 ohms wire.
Yeah.
Where you'll put the capacitor? I will tell you. The capacitor has to be placed, yeah? Exactly where is the noise source. Because obviously you want to cut that noise exactly from the source.
And where the hell is that noise source?
But who is creating that? Who is creating that? Who is modulating the power line? Or where is modulating the power line?
The coil?
Exactly. The coil, exactly. You have the MOSFET and the coil. The high current circuit, it's actually here. So this is the circuit of the high current. It's like that.
Yeah.
Now you have to understand. Yeah, you see this part from here to here? Check here from here to here. What is this? It's a wire, right?
Yeah.
Like here. It's a wire, like this wire, like I don't know, the ground wire. A wire is never ever a wire when we are speaking with switching or RF. Actually, here it's kind of RF. You have high frequency switching.
I don't know what's that.
RF is radio frequency.
Oh, okay.
But it's not that high, so it's kind of switching high frequency switching. So let's try together. Let's put a capacitor where? Connect the capacitor, please.
So yeah. From here to here.
From here? Here is no plus.
No. From here.
Yeah.
So from here.
Oh yeah.
From plus to minus.
But if it's from plus to minus, we can put it exactly here. On the wires, they come from the power supply. We have plus and minus.
Yeah.
Yeah, let's do it. So I will hold for you.
You hold for me what?
I will hold for you the capacitor here. The capacitor, I can assure you it's 100% connected.
Okay. And now?
Now let's check together.
There you go.
No, not there you go. Wait. Rise the duty cycle.
Yeah. Let me do it. It was like how much?
Okay, set up 100 milliamps.
Wait.
You can't do it, huh? You still can't do it. It's better, so you can set up at least 200.
Yeah.
So check here, yeah? This what is on oscilloscope, and you can still see some noise, right? Now, there's disconnected the capacitor. Check that.
Oh, the noise is bigger.
Exactly. So, connecting the capacitor.
It reduces the noise.
Exactly, the amplitude. Yeah? So, the amplitude of the signal. Yeah? So, it is better, but not good enough. You still cannot set up 200 milliamps. You cannot set up 100 milliamps. You can set up 200, but not 100.
But why? Because you need a bigger capacitor?
No, really. The frequency is quite high. You don't really need that big capacitor.
You can connect.
I just told you. Has to be connected the capacitor exactly where is the noise source. Where is the noise source? We spoke.
Yes, it is between the coils.
Exactly. So that's why connecting a capacitor here.
It
is better, but not enough because the wires, a wire, it's a coil.
Okay.
A wire, it's exactly like a coil. It will create a magnetic field. A wire has a resistance. Yeah, good. Connect the capacitor where you want to connect it. So you connect the capacitor?
Yeah.
Yeah?
Yeah. I don't know if I put those long wires, it should be shorter.
Should be shorter.
Yeah, I did not cut them.
Let's check. Let's see what what you did.
Okay.
See if you can adjust 100 milliamps. Huh? No, really? Huh? You can?
I don't know.
Okay, you can. Yes, you can. Now let's check together.
Right.
Yeah? Let's see. Huh?
Wait. Well, why is that happening?
I just increased the sensitivity on the oscilloscope just to see better what's going on here.
Okay.
But signals are still there. Switching is still there.
Yeah. And it's a big one. It's not like a...
No, it's big because I increased the amplification on the oscilloscope.
Okay. Yeah.
So actually the ripple is not that high, but it's still there. Now let's check yeah,
Mm-hmm.
before the wire or after the wire. Yeah? Yes, let's check straight to the capacitor, straight here, yeah?
Mm-hmm.
Just a little bit, you can see?
Yeah.
So basically, if you remove the wire and you connect the capacitor straight here, yeah,
Yeah.
because the wire is a resistor, it's a coil, yeah.
Yeah.
So you see, it's better straight to the capacitor. You can see that,
Yeah.
huh?
Mm-hmm.
So wires are not good.
Especially when I put a big one.
Yeah, but you get your power modulator. So if I will check the power here, check there.
Mm-hmm.
This is plus. This is minus. You modulate the power which is going to your MOSFET driver,
Mm-hmm.
and that it will affect the functionality of that one. So, what conclusion we can take from this?
Never use wires.
So remove the wires.
Yeah, but I still got like 100 million.
Yeah, but you still modulate this.
Yeah.
I mean, just because you can't see actually this working bad, you see now you can adjust the current, and just because it's working how it's supposed to be,
Mm-hmm.
that doesn't mean it's right. You have to do it right. So you have to get rid of any interference from the switching power supply. You don't want the switching to go on your power lines.
Yeah, so connect straight to the.
Yeah.
Yeah.
So connect the capacitor again. Okay, so the capacitor is connected, yeah, from the plus.
Wait, the bulb is not in the.
Yeah,
Yeah.
you can see
Yeah.
it there.
Okay.
Yeah, that's all. Okay, let's check. Let's check together. Let's see. It's good. You fix the problem.
Let's see. I don't know.
Uh-huh.
We get rid of the wires.
Okay, let's check together. Yeah, kind of. Kind of, you can see.
Yeah. What do you mean, kind of? It's a straight line.
It's a straight line, yeah?
Yes.
Good. It's a straight line.
Mm-hmm.
Okay. Now let's check what current is receiving your driver, yeah?
Mm-hmm.
So we have minus, right?
Yeah.
Minus and plus. Check that. That's the power which your driver, your PWM.
But what is this? Well, why is not straight?
Why is not straight?
Yeah.
Think how the switching can still goes on those power lines. So when I mean those power lines, I mean minus and plus.
Because it has a wire.
What has a wire?
This one.
It's okay. This is low power. It's taking a few milliamps.
Okay.
You know what I mean?
Yeah. So it's not that one.
No.
Um.
It's because let's see on the schematic. It's because you connected the capacitor, right?
Mm-hmm.
Exactly from here,
Yeah.
which is perfect. Yeah, exactly from here,
Mm-hmm.
which is fine. Yeah.
Mm-hmm.
So we have plus and minus. Yeah.
Mm-hmm.
And minus, you connect the minus where? On this capacitor here, right?
Yeah.
Yeah. Why is not working? Is because you have a wire. Remember, we removed the wire from the capacitor.
Yeah.
But you still have this wire from here to here. And of course, what is this? So you have one wire here, that's a resistor, yeah?
Mm-hmm.
And then you have another resistor like here, yeah? Which is a divider. So the signal from here, it will reach on the other side. It will not reach after the capacitor,
Mm-hmm.
but it will reach on the other side, on that direction. So you missed exactly this part. Yeah, you have a wire which is a resistor, which is a coil. So check here on your schematic. Where is that wire? Where is that wire? Is from the source of the MOSFET to the minus of the capacitor.
Yeah.
You understand?
Okay. But
What is the solution? Check the schematic. Check the schematic. What is the solution?
to solve to get rid of the wire, solve directly this one to this one.
Okay, let's draw it. Yeah. So that means the capacitor from here to here, right? Or even better, yeah. Let's say from here to here.
Yeah.
Right?
Mm-hmm.
You are kind of right. You are right. But that's why, yeah?
Mm-hmm.
That's why, because not always you can place the capacitor exactly here and here. That's why in electronics, yeah,
Mm-hmm.
you have different things. Like we have the MOSFET with the whatever is doing the MOSFET, right? Then we have the driver, yeah?
Mm-hmm.
The driver, the PWM generator, yeah?
Yeah.
Of course, they are connected together. Then you have plus and minus, yeah?
Mm-hmm.
Okay?
Yeah.
Good. Always, and that's a rule. You have to keep in mind this rule. Always, they are going on the same point, yeah? They are going to the same point, and from this point here, yeah,
Mm-hmm.
you put the capacitor to this point. Because on the capacitor pins, you have the lower interference because the capacitor is moving the current.
Okay.
You understand?
I'm not sure. Let me figure it out.
Okay, let me draw your actual schematic, yeah? So your actual is you have the driver, yeah? The driver, yeah, which is connected with the MOSFET and whatever that MOSFET is doing, yeah? It's good because you connect the capacitor here, but the minus of the MOSFET, yeah? So pay attention here, yeah? Right now, the minus is going here to the driver, and from here, like how you have now, yeah? From here you have the capacitor there, and then you come with the power here, plus, and you come with the power here, minus. You can't do it like that, yeah? So you either you're doing like this, yeah?
So you have to connect the capacitor like here.
No, you either you have two ways. You either like we spoke, yeah, connect the capacitor exactly on the source noise, yeah, on the switching MOSFET. So from here is minus, and it's going to the plus exactly here, or you use this schematic to handle the power distribution on your circuit. So basically, what do you have to do is not to get rid of this wire, yeah? You have to be sure your PWM generator or driver is connected straight to the minus of the capacitor. So let's check together. Your minus is connected where?
On the
You see?
Yeah.
So if you take this wire and you connect the wire exactly here on the minus of the capacitor, you solve the problem. Or you can leave the wire there, but you have to connect this pin exactly on the minus of the capacitor with no wires.
Yeah. So wait, either you take the black one
Yes.
and you connect it
Yeah,
there,
yeah, try it.
or you get rid of this purple and connect
Yes.
straight
Exactly, to the minus.
to there.
Exactly. Because they have to meet exactly on the same point, and the point it's exactly on the capacitor.
Yeah, but what will be the difference if you leave this wire or you take it out?
The difference is
Because I'm sure this wire it will do something, right?
it's a wire. A wire, it's a coil, it's a resistance. It's bad. You can't have wires on a switching circuit. That's what I'm trying to explain.
That's what I'm saying. It's not like.
Yeah, but we are not solving that problem now. Now the problem is we have modulated in amplitude the power for this one. So we have to solve this problem first, and after that we can have a look how we can optimize and increase the current flowing through this transistor. Yeah. So let's do it. Move the wire. Perfect. Let's check together now. So with the oscilloscope, we have minus, we have plus, Better.
Yeah.
Not perfect, but better. You can see we don't have any spike.
Mm-hmm.
Hmm?
Yeah.
Do you understand? What will happen if I check? Yeah. So this is here. Okay.
Yeah.
And after this wire, yeah, which is you said is just a wire.
Mm-hmm.
Check here. Just to understand how much the signal is changing on 10 centimeters wire. You understand how
Yeah.
much it's affecting a wire, this circuit?
Yeah.
So this is the switching here, and this is the switching after 10 centimeters of wire.
Mm-hmm.
You understand how critical it is to don't have wires on a circuit like this?
Yeah.
And check here, you have like a small wire here, you
I
have
know.
another wire
Yeah.
here.
It's full of wires.
So it is clear
Yeah.
how this schematic has to be built?
With no wires.
Yeah.
Yeah.
So indeed, we solved the problem. Yeah. So we don't have modulated current
Mm-hmm.
or modulated voltage on our PWM generator.
Mm-hmm.
But still, you are losing all. And you said, sorry, what do you mean a wire is a coil? What do you mean? Okay, let's check together. Yeah. So pay attention here. Just getting close
Yeah.
to the wire. Check there.
Wow.
You can see what a wire is doing.
Yeah.
Now let's check with your ground wire. Huh? Or with the coil. You can see, just getting closer.
Mm-hmm.
Or let me create a loop. Yeah. Now we have a loop. You can see,
Yeah.
look at the switching. And the coil. And this wire, check on this wire.
Oh, wow.
You can see on this wire. Yeah. Yeah, so that's what is happening with your wire. Now this is the coil.
Mm-hmm.
Check the coil. Yeah.
Mm-hmm.
And this is the wire. This wire.
Lot of noise. No wires.
Yeah, this wire.
Oh.
Huh? Check there. Check there. And you said, no, it's just a piece of wire. What can happen wrong with a piece of wire?
Yeah, it's a small one.
Look, if you check, it's warm. Here, check. The wire is warm.
Yeah.
Hmm?
Mm-hmm.
Kind of. So everything is clear?
Yeah.
Yeah? Good. Now, before we are stopping, yeah? Let's have a look again to the schematic. This one. Okay?
Yeah.
Good. Now, what is the voltage? You said like
33.
yeah, yeah, depends of what you adjust this one, right?
Yeah.
Yeah. So 33 volts, yeah?
Mm-hmm.
Good. Now, what I will do for you, and I will do it for you, I will order in this moment, I will order like a nice meal from that Chinese restaurant from Lakeside.
Mm-hmm.
If you can answer to a simple question.
Oh, I'm gonna starve today.
No, it's easy. It's
Okay.
easy.
All right.
So if here we have 33 volts,
Yes.
yeah,
Mm-hmm.
and we know that voltage came from the coil is bouncing back, yeah.
Yes.
So that voltage, we are getting a voltage, yeah, when the coil is bouncing back. So what is the voltage which the coil is giving us? The coil is generating. So what is the voltage the coil is generating?
What is the voltage?
What is the voltage, yeah,
Yeah.
which is giving us by the coil? So with what voltage the coil is bouncing back?
It's 12. With the same voltage that you apply, no?
What do you mean? Here you have 33 volts.
Oh. But you...
The voltage came when the coil is shifting the polarity, yeah?
Okay.
So the MOSFET is charging the coil, and the coil is bouncing back. And when it's bouncing back with inverse voltage, with plus here, the plus is flowing through the diode. So what voltage the coil is bouncing back?
33.
You sure? So you'll be starving today.
I was right then.
Yeah?
Huh?
And we spoke about this. We spoke
wait
about
a
this.
second.
We spoke about this.
So because hmm. Wait, it will be more than 33?
Huh? No, clearly you miss it. You miss it, yeah?
Probably.
So try to imagine like this, okay?
Yeah.
For 1 second. So imagine, yeah, this coil as being a battery, right? With plus and minus, yeah? Good. Which is connected here, okay? Imagine the coil is not there, it's a battery, yeah? Then what is the power supply? The power supply, it's another battery connected, yeah, plus and minus connected here. So what do you have here? Yeah, what do you have here? You have two power supplies connected in a serial mode. Minus of this one with plus of this one. So that's what you have. You have minus, you have plus minus, then you have another power supply, and we spoke about those power supplies. And this is your output voltage. You understand? What happens when you connect power supplies in a serial mode?
Oh my. Let's see if I remember. When you connect power supplies in the serial mode.
It's the same way when you connect batteries on a toy. You put batteries that are in the serial mode.
Yeah.
What will happen?
What will happen with what?
With voltage.
It will stay the same.
It will stay the same. Okay, let's check together. No, it's fine. It's fine. It's fine. So you have two batteries here, yeah? Check one battery only. We can't see. Actually, no one will believe if you cannot see.
I'm trying to.
Yeah. What is the voltage?
It's 1.3.
Okay, connect them on the serial mode. Yeah. Huh?
It's 2.7.
So the voltage?
It's added together.
It's added. Okay, what about the current?
The current, it will be high as well. Added. No, it's not. It will be stayed the same.
And on the parallel mode, the voltage is the same.
Yeah.
But the current, it's added.
Added.
Yeah? If they are not equal. I mean.
Yeah.
Yeah. So what will happen on our schematic then?
All right. Oh yeah. So.
What will be the voltage the coil is bouncing back?
It will be 24 volts.
33 minus 12. Because you have two batteries.
Why?
You have one battery here, yeah? And one battery here. So this we know is 12, yeah? The output we know is 33. So you have 33 minus 12, and that's the voltage of which the coil is bouncing back. Yeah. Which is how much?
It's 21 volts.
21 volts, exactly. So the coil is bouncing back with 21 volts. You have 21 from the coil and 12 from actually the power supply, because they are on the serial mode.
Yeah.
Now you understand?
Yeah, now it makes sense.
Oh, okay, so you lost the dinner. I'm really sorry. Maybe next time. Maybe next time.
Who knows?